Hi, let's look at this type 2B model sum question. Tim has 1/5 as many marbles as Jack. Glenn has 2/3 as many marbles as Tim. If Jack has 65 more marbles than Glenn, how many marbles do the three boys have altogether? Now, to do this, there are two ways you can approach this question. We will first look at the model, drawing the models and solving it from there, and then we look at it from the ratio perspective. Okay. Now, if I were to draw the model for this, okay, let's take it line by line. So in the first line, we are told that Tim has 1/5 as many marbles as Jack. Okay, so Jack has more marbles than Tim. Okay, 5 times as many. So let's draw it for Jack first. So Jack and Tim. Okay, so for Jack, we will draw 5 blocks. Okay, we'll draw 5 blocks. 1, 2, 3, 4, and 5. And Tim has 1/5 as many marbles as Jack. So for Tim, it is 1 block. Okay, so this represents the information from the first sentence over here. Now, in the second sentence, we are told that Glenn has 2/3 as many marbles as Tim. So Glenn has 2/3 as many marbles as Tim. So I need to break up Tim's block into 3 parts. And out of the 3 parts, 2 parts is what Glenn has. Okay, so Glenn has 2 parts. Okay, and these 2 parts are equivalent to the 2 small parts from Tim. Okay, now we are told that Jack has 65 more marbles than Glenn. Okay, now in order for us to compare Jack with Glenn, okay, we need to make sure that they all can be counted with the same dimension of blocks. All right, currently Jack is still having the big block size, which was used to form the relationship with Tim. Okay, but Glenn has a smaller block size. Okay, so what we need to do is we now need to match them all to a common block size. All right, and since we know that Jack's 1 block is equivalent to Tim's 1 block, and Tim's 1 block can be broken up into 3 smaller blocks. Okay, we can do the same for Jack. Okay, so for Jack, we are also going to do the same thing. We're going to break up each big block into 3 smaller blocks. Okay, and now that we have done this, we can see that each single block of Jack and Tim and Glenn are all of the same dimension. All right, so now that all the blocks are of the same dimension, okay, the smallest piece, we can now count them and compare them. All right, so what we are told is Jack has 65 more marbles than Glenn. All right, so for Glenn, this is the point, okay, where it ends, and Jack, it is over here. Okay, that means from this point all the way to this end over here, it is a total of 65 marbles. Okay, and once you have this information, okay, you can now calculate the number of marbles that 1 block represent. Okay, so we need to count how many blocks there are. So let's do that. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so we know that 13 blocks, okay, 13 blocks is equivalent to 65 marbles. Okay, so 1 block is equals to 65 divided by 13, okay, which will be equals to 5 marbles. All right, so once we know that 1 block represents 5 marbles, we can solve the question, which is how many marbles do all the 3 boys have together. So we need to know how many small blocks there are. Okay, so we have counted 13, so we can just continue counting. So from 13 there is a 14 here, 15, then 16, 17, 18, 19, and 20. All right, so we have a total of 20 small blocks. So 20 blocks, okay, will be equal to 20 times 5, which is equal to 100 marbles. So that is the answer, okay, for this question. Okay, so this is the approach using the model sums. Okay, now I'm going to show you the second approach. So this is approach 1. Approach 1. Okay, and now we're going to look at approach 2. Okay, and approach 2 is using ratios. Okay, so let's write out the information in ratio format. So we know that Tim to Jack is 1/5. Okay, 1 to 5. Okay, and the next information we know is Glenn to Tim. Glenn to Tim, which is 2 to 3. Okay, so the technique to approach this is we look at who is the common person here, a common item. In this case, the common person here is Tim. Okay, so we bring Tim to the center. Okay, so this is the center line, okay, for both of these ratios. So I'm going to rewrite it, okay, both the ratios, so that the Tim is in the center. Okay, so I'm going to rewrite it as Jack to Tim as 5:1, and over on this side, Tim to Glenn as 3:2. Okay, now what we need to do is we need to make sure that the numbers for the common item, or in this case common person, is the same. So on the right hand side I have 3, on the left hand side I have 1. So what I can do is, in order to make 1 to 3, I need to multiply by 3. So if one side of the ratio is multiplied by 3, the other side of the ratio must also multiply by 3. So this will give me 15 into 3. Okay, on the right side we still have 3 into 2. So now you see that the middle term, which is representing Tim, is the same number 3. Okay, is the same number 3. So with that, what you can do is you can straight away write it as one common line, that Jack to Tim to Glenn is 15 into 3 into 2. Okay, and once we have this ratio that represents all 3 of them, we can go back to the information that we have, that Jack has 65 more marbles than Glenn. Okay, so between Jack and Glenn, okay, the difference will be 15 minus 2, which is 13. Okay, so with that we can say that 13 units is equivalent to 65 marbles. Okay, so 1 unit is equivalent to 65 over 13, which is 5 marbles. Alright, and the total number of units is to add up all these 3. So 15 plus 3 plus 2, which is 20, is equivalent to 20 times 5, which is 100 marbles. Okay, so for 20 units, we have a total of 100 marbles. Okay, with the same answer from approach 1. Okay, so I hope that with this example you are clear how to approach such questions using both approach 1 or approach 2. Okay, so thank you for watching. I'll see you in my next video. Bye.